I will be telling you about some recent work that I've been doing in collaboration with some folks and some other universities here in the US that is bringing together not only paleontologists, but also geophysicists, tectonics folks, and climate modelers to look at how broad changes in landscapes over time have affected the fossil record, particularly of mammals in Western North America. So species richness varies across landscapes in relation to a number of different factors, and we've seen some great examples of those in the previous talks. And I am going to focus on only one of those factors that might be influencing the distribution of species across landscapes, and that's barriers. And so these might include topographic barriers that might isolate populations over time, and if they're isolated for long enough periods of time, that may promote the evolution of new species, the divergence of these populations into new species. And so in topographically complex regions where there might be a number of barriers to migration, that can promote speciation over larger scale or larger spatial scales and leading to higher species richness. And if we want to look in the fossil record to understand drivers of past species richness back in time, we can focus on areas that we know that have that have undergone a lot of tectonic activity in the past and that have very well-known fossil records. And so we focus on the Basin and Range region in Western North America, which has been forming over the past 35 million years or so, and in a very has undergone a dramatic landscape changes in that time. So this area was forming during the collapse of a topographically high region here. This is in this white area. This is known as the Nevada Plano, which is a very topographically high region. And as extension was proceeding over this area through time, this topographically high region collapsed and came down in elevation. And as extension proceeded, that led to the development of the numerous fault block basins that characterize the Basin and Range today. And so I was interested in understanding whether this high rates of extension were leading to not only the development of these individual basins that we know, but whether this was related to the accumulation of sediment in these basins over time was promoting the widespread preservation of fossils in this area over time, and whether that was contributing to this to the preservation of high numbers of mammal species during the Cenozoic. And so in order to do this, I was compiling the records of the number of mammal species in the region, sediment accumulation rate, extension rate, and area change rate for this region. And I focused not only on the entire Basin and Range, but I also looked at individual subregions of the Basin and Range, so the northern, central, and southern Basin and Range. And so the data for this study came from a number of mostly online databases that compile large records for either sediment deposits or species richness, species occurrences, and then tectonic literature sources came from the literature. And I used change point analysis to detect the earliest significant change between stable states in these time series. And so this is a way to look at the first significant time of change in these time series. And I limited it to one change in order to detect the earliest significant change. So for the entire Basin and Range, this is the time series going from 36 million years in the past up to the present. And so this first time series, this is the number of mammal species for the entire Basin and Range. And this is showing that the first significant change in mammal species richness occurred at 17.5 million years ago. And we see that this is occurring fairly close in time with the significant change in sediment accumulation rate for the region at 18 million, which was following the significant change in extension at 23 million, and area change rate was fairly close in time to the change in sediment accumulation rate. So this would seem to indicate that this change in extension that was occurring over the entire basin and range at about 23 million was preceding somewhat this change in the accumulation of sediment and area change that may have contributed to this preservation effect of burying more mammalian fossils in this region at about 17.5 million years ago. When we look at the northern basin and range, we see that the number of mammalian species increases again at 17.5 million years ago. And this is very close in time to the significant changes occurring in the other landscape variables that I was tracking. For the central basin and range, the number of mammalian species increased significantly at 17 million years ago, but we see a different order of the significant changes in the other landscape variables. So sediment accumulation rate increased several million years prior to this change in the mammalian species richness, and which even preceded the change in extension rate for this subregion, which is not what we saw in the northern basin and range. And then for the southern basin and range, again, mammalian species richness increased significantly at about 17 million years ago, but this was preceded by several million years of the significant change in the sediment accumulation rate, and extension rate was increasing significantly even almost 10 million years before that. So this change in the timing of the events is very different in the southern basin and range from the central or northern basin and range, indicating that these changes in the landscape variables are not necessarily related to the changes in the mammal species richness, which for each of the subregions was changing significantly at about 17 million years ago. So it does seem that mammalian species richness is decoupled from these landscape variables. And this change in mammalian species richness, the spikes that are occurring in the middle Miocene and later in the Pliocene, seem to be related more to changes in climate. So this spike in the species richness that occurred in the middle Miocene corresponds with the middle Miocene climatic optimum that was occurring at about 16 million years ago, which was the last significant warming episode of the Cenozoic. And then again, in the Pliocene, we see another spike in species richness that corresponds with the Pliocene warm period. And so it seems that species richness is responding pretty significantly to these changes in climate. And this might be because climate can be another type of barrier for species. And so we might know that species that are preferring colder environments will occur at higher elevations, and species that prefer warmer environments might occur at lower elevations. And so during cold climate states, those cold adapted species can move further down in elevation because the overall climate is colder. They can move between adjacent ranges and expand their ranges altogether and move all around the region. And then during subsequent warming intervals, when the intervening areas become warmer, the warm adapted species move back into the area, and the cold adapted species move back up in elevation, and that causes them to be isolated over time. So they're promoting speciation in these regions, and so this can be enhanced in topographically complex regions such as the Basin and Range, where there are a number of mountain ranges and basins in between that may be areas where species can become isolated at high elevations and be sort of areas where speciation is occurring over an entire region. Now, the sedimentation history is also important for the species, the preservation of fossils, and it seems like that is still contributing to the species richness, at least in the fossil record that we've seen for this region. So for most of the subregions, many of the earliest accumulating fossil deposits shown in green, or sedimentary deposits, which are shown in green, do not have fossil records associated with them. And whereas the pink curves are showing sedimentary deposits that have fossil records associated with them. And this may be because the sedimentation history is closely tracking the tectonic history. And so during these early accumulating deposits of accumulation of these early accumulating deposits in green, this corresponds with the time of the most significant tectonic activity in the region, when this Nevada Plano region, this high elevation region, was really actively extending and changing in elevation. And so most of the sediment in this region was being shed completely out of the system. We don't have records from a lot of that, but it's also not accumulating or forming environments that are conducive to fossil preservation.
You're past 10 minutes now.
Great. This may also relate to the change in faulting style that has occurred in at least the northern and southern basin and range. It's changed from sort of high extension, high magnitude extension detachment style faulting to block faulting that is what characterizes most of the basin and range today, which was occurring sort of asynchronously across the basin and range. And so that style may be, that change in style may also be helping to keep some of that sediment locally in these individual basins and over the region. And then I'll just note that this large spike in the central basin and range in the non-fossiliferous sediment is likely related to the opening of the Colorado River corridor. And is a much more recent phenomenon. And so another way that the individual lithology might be contributing to this, to the fossil record. So this is the proportion of different lithologies over the entire basin and range accumulation, sedimentary accumulation. We see that earlier on in the history of this region, a higher proportion of the sediments were coarser grained conglomerates, gravels, breccias. And over time, the proportion of the coarse grained sediments has declined in favor of finer grained sediments, sandstones, mudstones. And so this phenomenon would not only be helpful for the preservation of fossils in finer grained sediments, but this might be related to the individual environments that are forming in these basins. So the sedimentary facies and the environments that they relate to in individual basins may be influencing the fossil record in each of these regions, and may be enhancing our understanding of the spike in mammal richness that was occurring because of climate change. So in extensional basins, there tends to be a pretty well-known evolution of the environments in the basins through time. So the early forming phase of the basins that tends to be during active extension tends to accumulate lots of coarse breccias and sandstones in these closed basins, which are not necessarily able to preserve many body fossils, many bones, but also may not be attracting lots of mammals in these maybe very saline closed lake basins. Whereas later on in the opening phase of these rift basins, where the landscapes become more stable, they become more vegetated, and these are where finer grained sediments are accumulating and maybe better developed river systems or stable wetland environments. This is where mammals tend to congregate and spend time, and also these environments tend to be better at preserving mammal fossils. So the change in environments that are occurring in the individual basins may also be important and maybe contribute to this broad patterns that we see at the regional scale. So the sedimentation history is tracking landscape change fairly closely. Mammals seem to be tracking climate fairly closely, but the evolution of the individual basins and the environments there seems to be enhancing this the fossil record that's allowing us to track this change in the fossil richness through time. So I'd like to thank these funding agencies and people for their help, and I will take your questions.
Thanks a lot. There's time for 2 short questions, if there are any. Please type in the chat or raise your hands. Yep, there's one question. Derek?
Hi, thanks for the interesting talk. I've got a question about the extension rates. I was wondering how they were calculated. So some of the plots you were showing earlier in the presentation.
Right. So the extension rates came from literature sources, published extension rates, and so these are a little dependent on the published literature. So the northern basin range tends to be much better studied as sort of like I guess the part of the basin range that people focus on when they are looking at tectonics in the region. So there are more studies that have been published in that region than in the central and southern basin and range, but they're mostly focusing on just sort of displacement magnitude over time.
Okay, thanks. The next question is by René.
Yeah, thanks for the great talk. You mentioned that species diversity was enhanced during this warm period, mid-Miocene optimum and Pliocene warm period, and you mentioned that that perhaps relates to certain species, cold adapted species getting isolated in certain habitats and then diverging from others. If you look at the present, there's a concern that a lot of high altitude species are going extinct because elevational ranges shift upward and then certain habitats are being lost. Do you have any kind of like paleoclimate or paleoenvironmental reconstructions which would show what kind of habitats formed during these warm periods? Because I think if you compare them to today, they're really hot, so.
Yeah, it's certainly much warmer than even modern times for sure. Yeah, we do have sort of a climate component that we're adding into these analyses that is sort of in progress. So our goal, what we would like to do, or at least be able to understand better, is what the likely climate gradients would have been along these landscapes and how those would have changed through time. And so we assume that they would have become, I guess, they would collapse a little bit just because of the overall lowering of elevation in the region as a whole. But yeah, this is something that we're very interested in understanding much better. And so this is hopefully a forthcoming aspect that we can bring in the future.